Okay, we have here another integral from the Caltech Math Meet Finals number 3. We have the integral of inverse secant square root of x dx. And I've already done another video on this. What we did was integration by parts, and this one we can do a u sub. I guess there's a trade-off, with different methods, there's always a trade-off. I don't really know what people's preference is, so I just have to kind of try something. And so we'll do the u sub. So I'm just going to do a u sub for the whole thing here, and then let's invert it, and we get square root of x equals secant of u. Solving for x, we have x equals secant squared u, just squaring both sides. Take a derivative, we get dx. Derivative here, first product rule, 2 secant u. Chain rule on this is going to be secant u tan u du. Clean up this dx value by multiplying together the secants. We're going to have just 2 secant squared u tan u du, and we'll go ahead and substitute. So first, all this stuff is going to be u, and we plug in our dx, but let's take the 2 out as a constant. So we have secant squared u du. And I forgot the tangent, so we'll bring that back right here. Now I'm thinking this is actually more similar to the other method than I thought, because we did integration by parts on that anyway, so these are probably the same method. Maybe you'll only see one video if I find out they're too similar when I look at it. But anyway, let's go ahead with the integration by parts, because what's going to happen is this is going to be nice to differentiate, and this is going to be easy to integrate. So we'll use the DI method over here, and I think we can do these integrals in our head. So like derivative of u, that's just going to be 1. And then, you know what, let's bring the 2 back into it, just because I think that, I don't know, I just like doing it that way. So we'll do that, derivative of 2u is 2, differentiate again, and we get a 0. And then in the integral column, we're going to want secant squared u tan u. Now, if you were going to do it out, you'd do another substitution, like call this w or something. And then the derivative of it is right here. So doing it in our head, this is just going to be tan squared u over 2. Then for this one, we'll do the integral in our head, but what you'd want to do first is split this up using an identity. So you could write this as secant squared u minus 1. Then when we integrate it, we have 1/2 in front. Integral of that's just tan u. Integral of that's just going to be a minus, not an x, it's going to be a u. So for our solution in u, it's going to be on the diagonals. We don't need to worry about the integral. This is zeroed out. So what we can do, so let's see. I think now the 2's are all going to cancel, but when you multiply that, that's going to cancel with that. That's going to cancel with that. So what we're going to have here is going to be u tan squared u. And then for this, let's distribute in the minus sign. So we're going to have minus tan u, and then minus to this is going to be a plus u. And then all we need to do is just back substitute in order to finish it off. But one thing we need is our value for tangent. And so let's draw a right triangle, because we have a value right here for secant. So what happens for secant u, or if our angle is u, think of that like square root of x over 1, hypotenuse over adjacent, square root of x over 1. Pythagorean theorem, this is going to be square root of x minus 1. So using this, we can get tan u as opposite over adjacent, so tan u will just be square root of x minus 1. So now we're ready to back substitute everything. U is going to be inverse secant square root of x. Tan squared is going to be, if we square that, we're going to get just a x minus 1 now. Then we're going to minus this thing, square root x minus 1, plus our u, which is again inverse secant square root of x. But I can clean this up a little bit, because we've got like 1 copy of it here and minus 1 copy of this here. So what I can do is get rid of that and cancel off that. And so I'll just make a little space. And for my final solution on this, we get just x inverse secant square root of x minus square root x minus 1. Add a plus c, and that's it. Okay, there you go. Good one from Caltech Math Meet 2025. Thanks everyone for watching. Have a good day.